Remember that in order to be a factor of something, that you're going to have to divide that thing evenly. And dividing it evenly means that you have a remainder of 0. Well, the very last number that we get, we've noticed when we synthetically divide, is our remainder. So if that number happens to be 0, that means that the divisor, the polynomial we divided by, is going to be a factor of that dividend. Before I get to the next two examples, let's talk about what this means. So for example, let's say that I divide 2 into 14. So 2 is the divisor, 14 is my dividend. Well, 2 goes into 14 7 times, and I have a remainder of 0. Because the remainder of 0, we say that 2 is a factor of 14. That means that we could rewrite 14 as that divisor times the quotient. And right, that makes sense to us because we know that 2 times 7 is 14. Divisor times the quotient. Well, let's look at these directions because we're going to be doing the exact same thing in the last examples. Use synthetic division to find the remainder when f of x is divided by d of x. So this is the polynomial and this is the divisor. And we need to figure out, is d of x, is that divisor actually a factor of f of x? Well, what does that mean to us? In order to be a factor, your remainder has to equal 0. So we have to decide if it's a factor. The way that we do that is if the remainder is 0, then we're a factor. If the remainder is not 0, then we're not a factor. Then it says, all right, well, if it's a factor, then you need to rewrite f of x as d of x times q of x. So if you are a factor, if your remainder is 0, you need to rewrite what you're dividing into, the dividend, as the divisor times the quotient. That's all it's saying. All right, let's look at a couple examples and this will make a little more sense. So again, first, when we synthetically divide, figure out what c is. Well, this is my divisor here, and the opposite number with x is going to be -4. Upside down division bar, coefficients of my dividend go in here. So third power, second power, first power, constant. I don't have any missing terms, so I write 2, 7, -1, and 12. Bring down my first term. -4 times 2 is a -8. Add down -1. -4 times -1, +5. Add down +4. -4 times a +4 is a -16. Add down, I get -4. All right, I'm done with my synthetic division. Now, is this one a factor of that dividend? No. No, I'm not a factor. And the reason that I know I'm not a factor is that, remember, this was my remainder. And the only way that you're a factor of something is if that remainder is 0. Well, my remainder is -4, so I am not a factor. So it said to use synthetic division to find the remainder. Well, I found the remainder, and then we had to decide whether or not we're a factor. So my remainder is -4. No, I'm not a factor. I just answered the question. All right, let's go to the next one. What is C? C is 1. Upside down division bar. Put the 1 there. All right, I have a cubed, so 2, and then I need a squared term. No squared term. 0 placeholder. Linear. Constant term. Bring down my 2. 1 times 2, 2. Add down, I get 2. 1 times 2, 2. Add down, I get -1. 1 times -1, -1. Add down, I get 0. Am I a factor? Yes, I am a factor. Why am I a factor? Because my remainder is equal to 0. So yes, I'd be a factor. All right, well, what does that mean? Again, that this f of x, this 2x cubed minus 3x plus 1, can be rewritten as the divisor, which is my x minus 1, times the quotient, which is, remember, it starts with 1 degree less, so it's x squared, x, and my constant. So 2x squared plus 2x minus 1. So again, because my remainder is 0, my polynomial f of x can be rewritten as the divisor, x minus 1, times the quotient, which is 2x squared plus 2x minus 1. Alright, last one of these. Same thing. Find your divisor. It's -1. Upside down division bar. -1 goes on the outside. Then we have fourth power, third, second, linear, constant. I have all of my terms. So 6, -7, -11, +2, +3. Bring down my 6, multiply, -6, add down, -13. Multiply, +13, add down, +2. Multiply, -2, add down, 0. Multiply, -1, add down, +2. Am I a factor? Is x plus 1 a factor of this polynomial? No. Why no? Because the remainder is not 0. So that means, to answer the question that they wanted, no, not a factor. Alright, and we're going to be doing more with synthetic division and finding factors in our next section, which is talking about factor and the remainder theorem.